to BecodeTube. In this series, we are creating a neural network in both C++ and Python. I mean, the same algorithm in C++ and then the same algorithm in Python. We are using the MNIST database for the digits, handwritten digits. And in this video, we are finally gonna take a look at PyTorch because we are gonna convert our data into PyTorch. In this video, we are gonna see how to convert from numpy or Eigen to tensor, numpy in Python, Eigen in C++ into tensor. We are gonna create a model, a torch model. We are gonna create an optimize and a loss function in using torch, using the library. We are gonna train and test our data. Now we are gonna work with the torch library, but first I want to make a copy here of this file, and this copy I'm gonna name it PyTorch. But then here when we convert to numpy, this is fine. We split our x and y. We normalize the data, but here we are not gonna use our neural net anymore. And we are not gonna use this. The same thing for the testing. We are not gonna use our neural network. And we don't need to transpose the data. Okay. So once we normalize the data, we can call in our torch tensor. Before that, we need to import the tensor here. We don't need the neural net anymore, so we pass in the torch there. And now we tell it that it requires grad because we are in the train data. In the test data, we don't need this. And we need to convert this train x into float values. Our y, we can just convert it to tensor and we are ready to go. And we can just print the tensors to see if it's, we have the correct shapes here. And the same thing for the test. We remove here this neural net, and here in the test we convert to tensor, we convert to floats. Our y is directly converted, and we get the shapes here. Let's what's complaining here? Oh, because we don't use this, but we are gonna use later. Run. Here our tensors, they were correctly parsed, so we are good to go with the Python. For the C++, we also gonna copy the file, paste it, copy. I'm just gonna call this torch. We don't need our neural network. So we don't need this. We don't need to transpose. We don't need all of this. Our loop can remove these outputs. We don't need from the transpose. Okay, clean up the data here. Now, I'm gonna create this function here that's gonna convert Eigen into tensor. So, as I mentioned in my first video, this was a discussion in the PyTorch forum, and I need to include the torch. But to do that, I need to include in my settings the torch. It's this one, the include. So here, and then this one. So for the torch, we need these two includes here. In this function here, we are getting a matrix, Eigen matrix, and we need to convert to a tensor. So first, we create an empty tensor with things transposed here, columns and rows. Then we get the pointer for that tensor, converted to float, and then we create a map of Eigen matrix using that pointer. But then when we cast the input matrix as floats to this map is mapping the pointer for the tensor. So then Eigen is basically copying the data from Eigen into the torch tensor here. But then we need to return the tensor transposed. And we are gonna need vectors transformations too, because this will be used for the x values and this will be used for the y values. So same thing, we receive a vector in Eigen, we create an empty torch, we get the pointer for that empty torch. Eigen creates a map of this pointer to the memory, right? Memory of Eigen and memory of the data. And then when we cast all the values to float, we are copying the whatever is in this memory for the Eigen into the tensor that we created here, the pointer of the tensor. And then we return the tensor once all the data is copied there. Now we can go back here where we convert the matrix to tensor. We tell the tensor that it requires gradients. So this is because this is the trained data. For the test, we don't need this. So we convert our y vector into a y tensor. But here we need to convert this y tensor into an integer, in this case a long value, a long integer, which in the Python it's the opposite. In the Python we need to convert the x into floats, but here in the torch we need to convert the y into long integers. We can just take a look on the sizes here. And for the test, same transformations. We first transform the x into a tensor, then the y vector into a tensor. We convert the y into a long type, and we are going to print the results here. In the CMake, we are going to need some changes. We need to find the torch library. It's gonna update here, but it's gonna throw an error. Oh. Okay. It could not find the torch because we didn't pass the location. So now dependencies for the torch, it's here. So here torch. And we have a new executable. I'm gonna add it here. But this new executable, we are gonna need the MNIST, because the MNIST is our data set that we read from the original files, and we need the torch libraries. Just to take a look at the torch libraries. So these are the libraries that we would have to link. For some reason, these two here give the full path, but as long as you are using the variable here, you're fine. But then when we install this target here, we want to install in the bin folder. Okay. So then let's build to take a look. Okay, but if we try to run this, it's not gonna work because we didn't pass the libraries. So to do that, the torch, the lib folder. So we grab this. Let me clear here. If we export the LD library path, I want to keep what I had before. And I'm gonna add the torch library here. Now if I run the torch, we get the data as we wanted, the x sizes and y sizes for the test data and for the train data. Again, if you installed Torch on your system, on your user local, or in your just user, or maybe in your home, you won't need to export the library, but if you are following this video, make sure that you export them to the LD library path. And then you can run the program. Now we need to create our model so we can use the Torch library. Here I'm gonna add a new folder, torch.net, and I'm gonna create here a new file, torch.net.py. So here I'm creating a network. It's gonna receive the number of features. So this will be the 784 number, which is the 28. The image is 28 by 28. What's the hidden layer size? Will come from the config ini. The categories we are calculating here. The categories. It could be an input from the config file too. What we are gonna have here is one first layer that's gonna receive the number of features in the hidden layer, then the output layer, and a relu and a softmax functions here. And the forward propagation is we forward our input, so our x values, into the input layer. Then the result, we do a relu on the result, and then on this we calculate our output, forwarding this to our output, and at the same time we calculate the softmax of this output, and the result from the softmax we return to the user. We use it by importing this new network that we created. Here we create the object. So the number of features is the shape 1 from the X, or the number of columns in the X. The hidden layer is an input. And the categories we are calculating here, but could also be an input if you have a different data set. And here we are gonna telling it that's trains data set. We are not training yet. It's just telling it, hey, do a training, prepare your gradients and stuff. Our optimizer function is gonna be an SGD, and our loss functions is gonna be a NLL loss function. Let's create the same model in C++. Here in the source folder, I'm gonna create a torchnet here. Torchnet.hpp, no, cpp. They include also a torchnet.hpp. Actually, we are not gonna need a CPP here. We're just gonna need the header because it's just a struct. So we are gonna have the same inputs, the number of features, the hidden layers, the number of categories. We are gonna create a linear layer for the input and another linear layer for the output. The forward, we take the X, we forward to our first layer. This first layer we put in the ReLU function. Then this result we send it to the output. This output we do a softmax on the dimension 1, which is the same as we see here, that a dimension 1 is set here when we create the softmax function. In the C++, we set the dimension here when we call this function here. But the structure is the same. 2 layers, a ReLU after the first forward, and a softmax before the output. In our torch, we include this new network. We get the object here. So the number of features is the number of columns in the X matrix. The number of hidden layers are under the categories here. And we tell it that we are gonna train the data. So the same optimizer as GD, passing here the alpha as the learning rate. And the loss function is the same, NLL loss for this network. Now let's use this network that we created. So first, in our optimizer, we zero the gradient. We forward our tensor into our network, receiving an output. We verify the output against the loss function to get the loss value. And then we do a backward to update the loss function. And we step the optimizer. Then at each 5th generation, we get what's the maximum on the dimension 1 for this output, and we check if they are equal to the Y tensor. This way we get if the prediction is 0 or 1. We have to convert this to integer. Then we sum, and this sum is going to return a tensor. So then we have to get the item from the tensor. Then we get the integer value here. With this integer value, we calculate our accuracy. Then, to get one final prediction after all of the generations, we forward again the xtensor, we get the predictions, we get we count the correct predictions, and we calculate the accuracy. And for the test, it's the same, but now we pass the test tensor into our network. We compare with the y tensor, this output, we convert to integer, sum, and get the item from the tensor, and we calculate the accuracy. Let's see. So with this data set, we just for the training we get up to 86%, but with the test we get to 78%. And again, we need to change here the generations, the hidden layers, and the maximum items. Then we get better results here. Now let's run for the C++. We are gonna need these tensors. Here we tell the optimizer to zero the gradients. We forward the xtensor into the network to get the predictions. We forward the prediction and the y tensor into the loss function. We backward the loss function, and we step our optimizer. Then for each fifth generation, we get the max in the y dimension. This returns a tuple, that's why this is a tuple. So then to get the values, we get the 0 index, and the indices, we get the 1 index from the tuple. We compare the y tensor with the indices. So the indices from the max, so it's gonna tell us which on the prediction gets the highest value. So then that index is related to the y label. So this is a boolean. We need to convert the sum, get the item as integer, so then we get the value here, and the accuracy is how many correct predictions by the total rows that we have in our y labels. I just need to include here these variables. So then at the end, we do one last forward. We get another prediction. We get the max indices, compare with the train, calculate how many correct predictions, and calculate the accuracy one last time. Then for the test, here I'm creating the variables that we need. I'm forwarding the xtensor into the network to get the predictions. I'm getting the maximums, both value and indices. We compare the indices with the y tensor, and we get the value as integer. I need to count how many. This can be a vector, and this you're gonna sum to count how many correct predictions we had, and we're gonna print the results here. Let's build. Okay. Begin. Torch. Alright, just 9 seconds and we get here the test almost 80%. If we increase here the hidden layers, we probably get better results, increase the generations and stuff. I'm here on my Windows. I'm gonna compile now on Windows. I'm sorry I did not compile for the previous videos. But here we have to make some changes, right? So this is Linux includes, and here Windows includes. For the OpenCV, we need the libtorch. So dependencies win libtorch include. We need this one. We can just use double slashes here. And we need this API. So it's torch the source API include this. Again, just quick change here. The OpenCV we already did that, and the Eigen, it's the include Eigen. So dependencies Eigen include Eigen. So up to here, this one. Okay, these are the standard libraries, and here we also need to change. These are the Linux. For the Eigen, we need the share remake here. And for the torch, cmake, no, lib, no, share, cmake, torch, okay, now, correct one, and the torch, d equals, okay, and in our config, I need to change here the correct path, copy path. Yeah, it's gonna reconfigure. Found the torch, got the Eigen, includes directories, OpenCV. I'm gonna change to release. Everything's okay. If we install, there. Oh, my bad. Here. Okay. Build. still configuring. Build. Okay, it's done. Let's try to run. It will probably fail, but because of missing libraries, but it failed because we don't have the opencv on my path. So x64 lib, no, this libs here. I need to set my path, that path equals this and the path. So now it runs. If you want, you can set your path in your Windows configuration. I'm not gonna do that because I'm just using this for this project, but if you want to keep using this, then check your Windows environment and add the location for the DLLs into your path. And the same thing for the torch. If I run the torch now, it's also gonna fail because we don't have the path for the torch here. So the torch lib, so we need this into our path. So set path equals this and the previous path. Now if we run the torch, just remember that if your path has space, then you add quotes only for your path. Let's say if you have something like this with a space, you add quotes only for your new path and you concatenate the old path at the end, right? Notice that this was running the IntelliSense for C++. I paused it. Let's see if it's gonna. So a little bit better. The startup time was faster, and converting from the binary to the matrix takes a little bit time in both train and test, but still reasonable time. That's it for this video. If you like it, don't forget to click on like button, share with your friends, and let me know what you think. Thanks.